Welcome to Chapter 2. We're starting with Section 2.1, Linear and Quadratic Functions and Modeling.
This chapter guaranteed to mess you up a little bit, so you want to make sure that you...
Why would you start off that way?
Well, because they need to be warned.
Okay, this is your warning. I don't think that that's true. But...
Baby steps and you'll be perfect.
Okay, we're starting off with the definition of a polynomial function. You've got all of this math jibber-jabber here, which is basically telling us that if we have a polynomial function of degree n, we've got the leading coefficient there is a of n, which is good.
Writing a polynomial.
Oh, you're writing a polynomial.
I'm just going to, for example.
Here's an example of a polynomial function that you might see in your day-to-day life. I think there's also maybe some examples on the next slide.
Nice.
Don't get too carried away.
I won't.
Okay, so there's a polynomial. Like most things like you've done so far have been polynomials in like Algebra 2. So the key to a polynomial function is the exponents of your x's have to be 0 or larger.
Integers?
Integers, yes. Integers that are 0 or larger. So that -1 there, how does that have an exponent of 0 or larger?
It's really cool. This guy is a super secret one. He is x to the 0 power.
Because anything to the 0 power is 1.
Your dead grandma to the 0 power?
I don't have a dead grandma.
I do.
That's awkward. So, I think that's what we need to know about polynomial functions.
Rock on. Slide 2 coming up.
Okay. All right, so we have a basic definition of polynomial functions. Example 1 asks us to determine which of the following things we've got here are polynomial functions. For those that are, state the degree and leading coefficient. For those that are not, explain why not. So f of x equals 2x squared minus 3 plus x to the 5th. Is that a polynomial function?
The secret is in the exponent. So do these meet the requirements from the previous slide? I think they do.
They do, because they are integers, they are 0 or greater, and really you can just ignore the -3. Anytime you have a number, the number is going to be fine. A number is a polynomial. So the other exponents work out, so that is a polynomial. Let's talk about degree. The degree of the polynomial is the biggest exponent.
Just a quick reminder.
Yeah, that's why this is a polynomial. Okay, the degree of a polynomial is the biggest exponent. Yes, the biggest exponent is what?
The biggest exponent in this case is Fiver Fever right there.
So the degree of this polynomial is 5. Then we also need the leading coefficient. The leading coefficient is the coefficient that's in front of wherever we got the degree from. We got the degree from where he circled in green. And so what's in front of x to the 5th? Well, nothing, but actually there's a 1 there.
How many x to the 5ths do you have?
I have 1. LC stands for leading coefficient there.
That is correct.
Okay, so there it is a polynomial, degree of 5, leading coefficient of 1. G of x equals 4x to the -2 plus 3. Is that a polynomial?
The evidence is right here inside the exponent.
We cannot have a negative exponent and have it be a polynomial function.
I say shenanigans.
No, really, that's the way it works.
No,
It's
shenanigans, not a polynomial.
Okay,
Yes.
not a polynomial.
It's shenanigans as in not a polynomial.
Okay.
Not a poly. It doesn't want a cracker. I'll be here all year.
Yes, you will. And the reason is because of the negative exponent.
-2 is not bigger than 0 or an integer bigger than 0.
Yes.
It's not bigger than 0.
It's
It
not
fails the
bigger than
first
0.
guy.
Fails it. Okay. H of x equals 9. Is that a polynomial? Well, we kind of actually said a couple of times already how this whole there just being a number thing works. It's really like there's an x to the 0 next to it. So that's got an exponent that's 0 or larger, an integer 0 or larger. So that is a polynomial.
Let me get the right color here. So polynomial. It does want a cracker. Poly wants a cracker.
Okay. Because poly only eats 0 or larger integers.
That is correct.
There you go. And so our degree is the exponent we have there, which is 0. So the degree of 0. And its leading coefficient then is what's in front of our x to the 0, which is 9. Example 1 done.
I can't type that.
The first thing we're going to talk about specifically as far as polynomials go is a very specific type of polynomial function called a linear function. It is a polynomial function of degree 1, and it has the form up there. It says f of x equals ax plus b, where a and b are constants, and a does not equal 0. You may be more familiar with it as being y equals mx plus b. That's saying the same thing. Point slope form, which he just drew an arrow to, is like the most important formula, I would say, in the world.
I mean, if you can do point slope formula, you can do anything, but you can't do like slope intercept. Like, that's only good for slope intercept. Point slope.
Point slope is the best way to go.
You're going to use it in conic sections, which is going to be in the spring. You're going to use it with any parent function that you investigate. It's going to be all over trig.
Yeah, it's just all the time.
It's
point
there.
slope. Let's
Yeah.
use it. So what that formula looks like is it has a y and an x that just stay as y and x. It has m, which is the slope of the line, and then you have to have a point, which is the x1, y1. And you plug in the slope, x1 and y1, and then that's your equation of your line. And for the purposes, especially of the AP Calc test, there is no reason to simplify that into slope-intercept form.
No reason at all.
You could if you wanted to.
But you make a mistake and you're toast.
Yeah, so we would like for you to just leave it as point-slope form. And they were crafty with the name. There's a point and the slope, and it's right there, and it's called point-slope
Some
form.
genius did that and has earned thousands of dollars.
I seriously doubt that.
Well, maybe.
Maybe Mr. Point or Mr. Slope could tell us otherwise.
Well, it's like the one guy proved that if you have 6 pigeonholes and 7 pigeons, that one of the pigeonholes has 2 pigeons in it. And he got paid a ton of money to do that. So I'm just saying it's possible.
I don't know where that came from. Example 2. This is exactly like some of the problems in our assignment. So write an equation for the linear function f satisfying the given conditions. The way they wrote this is weird. They are telling us about 2 points because f of x means that what's in the parentheses is what x is. So we have a point for this first one. That would be -3, 4.
Sorry, -3, 4.
-3, 4 is our first point that we get from f of -3 equals 4. And then our second point would be 3, 6, because we have f of 3 equals 6. Now we need to find the slope, and then we need to plug into point slope. So I didn't put the slope formula on there. Maybe we should put that somewhere.
Here's what you do. You stack your points up like this and you just subtract them.
Oh, well, that's one way of doing it.
How about that? And then,
then
you
you
do
put
y
y
first.
over x.
So you're going to do 4 minus 6 over -3 minus 3. Order is taken care of. Nothing gets out of whack. Everything's appropriate. Sign is good. So I have -2 over -6, which I believe is 1/3.
That's right, because the negatives cancel each other out. You divide by 2 on the top and bottom, so that's 1/3. What if you wrote out the slope formula? Just in
If
case
I
somebody's
wrote out the slope formula,
really
one thing that will super come in handy in calculus classes, if you just get into the habit of always going your stopping point minus your starting point, which would look something like this. y2 minus y1 divided by x2 minus x1.
And that's what he just did.
And that's your slope.
Okay, so that's our slope. We need to take that in one of our points and plug it into point slope formula.
I choose this point.
Okay, let's choose that point. So that's -3, 4. That's our x1 and our y1. So we plug it in. Y minus y1, which is -4, which is 4, equals 1/3 times x minus a -3. Now, the minuses next to each other there, you might notice you do that thing that you learned a long time ago, ching chang, walla walla bing bang. That becomes +3. So there you go. That is the equation for the slope of this line. We could also, though...
Ching chang, walla walla, bing bang.
Yeah.
I like it.
Yeah. Isn't that how they learned it?
I think it's a click was how
Click,
some of
click.
the,
I
some of the
couldn't
kids
remember it.
learned
Click,
the click
bang, bang, bling, bling, whatever. So if you were to solve this for y, we don't have to. Why are you solving
You
for
know,
y?
some kids just, they're real OCD about how they like their problems to look, so, you know.
If you wanted to solve for y, you have to add the 4 over, you have to distribute the 1/3.
No, you don't have to. You could, you know, you could leave it like
Oh.
this.
Well, okay.
I think
Okay.
both of those are good.
Okay.
You know, some kids just like to have a y all alone.
Okay. We need to graph it.
Right, well, I'm out of space.
Up there in the right
Okay,
corner.
up here, right corner. So I'm going to graph the point negative 3, 4.
Negative 3, 4.
Negative 3, 4. There's my point. My slope is down 1, forward 3, or I could just plot the other point.
Don't you mean up 1?
That's what I
over
said.
3?
Yeah,
Or
so
you could just plot the other point and draw the line that goes between them.
3, 6. And I'm going to connect those suckers with a straight line.
Straight-ish. Connect.
Okay, so hold on.
It's okay. Don't worry about it. There it is. There's the point.
There we go.
Good to
Right through.
So
Perfect.
there's actually more than one answer to this, though, right? Because they could have used the other point.
They could have.
So you could have gotten y minus 6 equals 1/3 times x minus 3, and then that would be from the other point.
Exactly.
All right. Quadratic functions and their graphs. This slide is loaded up with a lot of information.
Chock full of goodies.
The first thing you need to know is a quadratic function is a polynomial function of degree 2. Its graph is a parabola. The standard form for a quadratic function is given up there. F of x equals ax squared plus bx plus c. That should look familiar because that's what we use when we're doing like the quadratic formula and stuff like that. Vertex formula. Either the lowest point or the highest point of your parabola, that's the vertex, depending on if it opens up or opens down. If it opens up, it's the lowest point. If it opens down, it's the highest point.
Yep.
And so the way you can find that from standard form is this little formula we've got, negative b over 2a. You find that, and then you plug it into your function, and that gives you f of negative b over 2a. Or sometimes they give it to us in vertex form, which looks a little different. It's down there, right there.
And anytime you can work straight out of vertex form, that's always easiest with parabolas.
Yeah.
Like every time.
Don't like try to FOIL it out and multiply and stuff, because it actually is easier. Because the vertex of that form is h comma k. Like whatever's inside, you do the opposite of. Whatever's outside, you leave alone. Just like when we talked about transformations and
Yes. The super secret opposite society is in
Super
full
secret opposite society.
bloom inside parentheses.
Yes.
Anytime you're inside parentheses.
Anytime you're in parentheses, you change the sign. So that negative h, it becomes positive h for our vertex, and the k on the outside continues to be positive k.
That's correct.
The axis of symmetry, depending on which way you found your vertex, it's the x value. X equals whatever. It'll either be negative b over 2a if you found the vertex that way, or it'll be h if it's our... So, I don't know where we left off.
Well, we were talking about the axis of
The
symmetry.
axis of symmetry. If it's in vertex form, the axis of symmetry is x equals h.
And if...
Are you going to write that?
Yeah, sorry.
So it depends on how you found your vertex as to which of those two things you would use. So why don't we draw a parabola and just point out, like,
I know what
we're
this looks
talking
like.
about.
No mocking my skills.
Y equals x squared. Well, the scale there is a little tricky. Tried to
I'm
trip you
paying
up.
attention. I'm paying attention. Oh, wow. This is way up. I'm just going to go with right here.
That kind of looks like a B.
Yeah, I'm going to curve it at the bottom. It'll be, you know, it's going to work. It's going to work really bad. No mocking, Mrs. Stevenson.
We
my
all know that
artwork.
this is a parabola, so it'll be okay. So this y equals x squared is what he's graphing right now. If there is a positive in front of your x squared, it is a parabola that opens up, which means that the very bottom point is your vertex. And so since we didn't have anything being added to either our x in parentheses or outside of parentheses, our vertex form, it's kind of in vertex form because our vertex is at 0, 0.
Yep, x plus 0 is x.
Yeah, and so then we could talk about the axis of symmetry being the line x equals 0, the line that is vertical that goes through 0. And what we mean by axis of symmetry is that's where if you fold it, hot dog style, it looks the same on either side.
Mirror image, except for this one, which of course is not perfect. We've all had a chuckle. Let's move on.
Okay. If we were to graph y equals negative x squared, what changes?
I'm just going to freehand this one because it'll be better.
That is so much better freehanded. That's amazing. Where was that before?
You know, I was saving it up for later.
The negative, if we remember back to our transformation rules, it's not inside the parentheses, and so this is a reflection over the x-axis. And so that just means if you see a negative in front of the x squared, that means that it is a parabola pointing down. And so our axis of symmetry, since we didn't move left or right, is still at x equals 0?
Yep.
Yep. What about that crazy thing down there?
Well,
y equals 2 times x minus 2 squared plus 1.
The super secret opposite society is now kicking in, so that means my vertex is going to slide to the right 2 times. So
Yes.
he is now going to, let me get a little bit of a color difference here.
Okay.
And so here's my new vertex.
What about up 1?
Well, and then I hadn't got there yet.
Oh,
so
okay.
I slide to the left, slide to the right 2
Slide
times,
to the
and then
right
pass
twice.
the duchy up once. You know that one song? Pass the duchy to the left one time.
And then vertically stretch by 2.
So instead of coming over here to my, to 3 and going up to 9, I'm going to go up to that times 2.
Right.
Yeah. So
It times your y values by 2.
2. So I can't even put that on this graph.
Okay.
But it's really thin. I'm going to freehand this again. This is going to be totally great.
So
Actually, let's see.
While he's freehanding this,
0.
or whatever, the important thing is that our vertex was at 2, 1, so that's now our bottommost point. If we were comparing this to the graph of like y equals x squared, we know that it's thinner because we're vertically stretching by 2. All of our y values end up being doubled, and if you're trying to make this accurate, like vertically stretch it first and then move it is the easiest way to do it, in my opinion. I'm not even paying attention to what you're doing. And since it's a positive 2 in front, remember that means it opens up. If it had been a negative 2 in front, it would open down.
It's like I feel like I grabbed something wrong here. 0 minus 2 squared is 4 times 2 is 8 plus 1 is 9.
9.
Okay, so it's 0, 9. And by axis of symmetry, if I'm at 0, 9, guess what? Over here at 4, I'm at 9. And so here is my graph. Almost. Yet again. I got to quit putting points down.
Since our vertex was 2, 1, our axis of symmetry would be the line x equals 2, because the axis of symmetry just takes your x value from your vertex right there at x equals 2. So there's our quadratic functions.